One by one, are you? At that point.
Alright, any parabola with a positive value looks like this, while a parabola with a negative a value looks like this. That's all I was looking for bow work today, short and sweet. I am now going to head to some questions for you to do as classwork. So it's like 5 questions. You do it right underneath bow work in your notebook. So everybody has their positive and negative parabolas drawn underneath today's date, 10/1/24. As you notice, this chapter has over 100 pages in it. It's a long chapter. Your test right now is scheduled for November 1st, so 1 month away. This chapter is significantly longer than our last one. I will help you. Just a moment. Let's head to classwork for everybody who's ready. There will be time at the end of class also if you didn't finish hole punching. So you can move forward calmly knowing you will have time to accomplish that momentarily. Alright. Here's your classwork today. You're going to turn to page 181. Yours good?
Can you help me?
I am going to help you in a moment. Alright, page 181. And you're going to answer these questions. The first question you're going to answer is, what is the root of an equation? Answer in a complete sentence in your notebook directly under bow work. The second question you're going to answer is, what 3 methods can be used to solve quadratic equations? The next question you're going to answer is, where are the roots of a quadratic equation on a graph? Then you're going to read example 1, and you're going to answer, does the textbook explain how to graph equations? And then you're going to do number 5. So that's what you're going to work on for the next few minutes, and I can help anybody who's still working on hole punching. Correct. Underneath your bow work.
Well, what are we working on?
I will finish this for you.
Yeah, but one by one.
You just focus on that task. It'll get done before you know it. So in order to direct your attention to the important parts of this page, I've written these questions for you to help you understand where you should focus your attention as you're reading the book.
Wait, so we don't know it? We just have to read it?
Yeah, read it. Find the answer on page 81 and write it down. Yeah. So use the information on page 181 to try to answer these. This is new information to you. You got it going? You finished? Let's do it. Let's start. Yeah. Nothing got it.
Okay, if I did it.
I'll take that one.
Are you serious? Oh my goodness. No.
Keep it in your brain.
I can't.
Oh, God. You want the play.
Yes. I don't
Yeah. Okay. On this. Alright, I'm gonna go through these answers since we have quite a bit of chatter. Jaden, have you answered the question yet? Okay, he's ready to move on. Let's move on.
What? Hold on. What?
Let's see answer to number 4. Does the textbook explain how to graph? Alright. It says on page 81 that the root of an equation is the solution of the equation. This is a vocabulary word. So on November 1st test day, one of your vocabulary words will be roots of an equation. You should just state it in a complete sentence. The root is the solution to the equation. So that's interesting and annoying. I get kind of annoyed by this. Why can't they just call it a solution, right? So I'm going to go ahead and state that a root is a solution. They're synonymous. They're equal. I mean, there's like tiny difference, but it does not matter in algebra 2. So the root is the solution. What 3 methods can be used to solve? You can solve by graphing, which is cool because you guys already know how to graph. Graphing is something you already know how to do. What was the second one, Jaden? After graphing? Oh, square rooting you guys are also good at because you do that in geometry with the Pythagorean theorem. So that one's cool too. And the last one is factoring. Now, factoring is a doozy. Some people are just blessed with the talent of factoring. Literally, they see numbers and they know their multiplication tables really well. They're very good with putting together positive and negatives, and factoring comes easy to them, to be honest with you. Some people will be factoring very quickly, and you'll go, how are you doing that? Well, some people just have a little number talent. Just like people are talented at running or at music, people are talented at math. So you will be surrounded by some math talent when it comes to factoring. The rest of you guys who don't have that less talent will just practice it. Factoring might take a lot of practice for some of us to figure out. That's okay. But what I want you to know is factoring occurs in every chapter of the book. Okay, you want to know how to factor. You want to stick with it and practice it long enough to figure out. So we're going to solve by graphing, square rooting, factoring. There's 2 other ways we actually solve with, but not in this first section. All right, Jenny, that's it for now. Go sit down. No more. Don't make sitting. No more. All right. Where are the roots? Did anybody figure this out? It wasn't really written out that explicitly. Where are the roots of a quadratic equation on a graph? Anybody besides Jaden? Where are the roots on the graph? Yes. The x-intercepts are roots. So I'm going to go ahead and add to my little equation here. I said a root is a solution. You know what it also is? It's also an x-intercept. Okay, so a math test or textbook or question could ask you to find roots, could ask you to find solutions, and it could ask you to find x-intercepts. They're all the same thing. Okay, they all represent solutions. Now, in the textbook, it shows you to solve by graphing. Does it explain how to graph, Vincent? No, the book does not explain how to graph. By chapter 3.1, your Algebra 2 textbook assumes you know how to graph a parabola. It was already covered in chapter 2. If you cannot remember how to graph a parabola, go to chapter 2.2. So that might be one that you don't want to throw out. Or I gave you a handout about how to graph. You can use your handout as well. So it doesn't tell you. It says to graph. It doesn't tell you how. They're assuming that you figured that out in chapter 2. We have already tested graphing parabolas. Now we're going to go to page 189. And we're going to do 1 through 4. I'm going to do number 1 with you, step by step. And then you guys do 2, 3, and 4 on your own. So as I look around and I see you on page 189, I know you're ready to move on. I can wait if you're not ready. This is your assignment today, so whatever's not done in class today, your independent work at home or wherever it is you do. Gym, field, cafeteria, car, drive, places.
Oh, no, I remember.
Okay, you ready? Page 189, number 1?
What?
Are you ready?
Oh, yeah.
You are? Well, let's do it. Alright, so here I am. I'm going to go ahead and right above these directions, I'm going to be a little more clear. When it says solve, it doesn't mean just create a graph. We've done that before. Specifically, it means find the x-intercepts. So go ahead and add that. When it says solve by graphing, it says you're trying to find the x-intercepts. And they're also informing you from page 181 that those are called roots for whatever reason. Maybe that's where they like hook into the ground. I don't know. Okay, so we're relying on past knowledge to get this graph done. I remember when we talked about graphing before, we labeled what A, B, and C were. We listed A, B, and C. There's an invisible one here. Oh. 1, 3, 2 is A, B, and C. Yeah, good question. Typically, we would see equals Y, right? Now, when someone goes to solve a quadratic equation, they take the Y out and they put a 0 in. That's a really interesting point you pointed out for us, Kenny. It says equals 0 instead of Y. As we graph it, we're going to think of this as Y. But when you solve equations, you do want them set equal to 0. So actually, since you brought it up, when you look at number 4, there's a problem. Number 4 is not equal to 0. What do you think we should do, Kenny? What? Number 4 doesn't have the 0 like the other 3. You add the 8. So make it equal 0, okay? So since this has been brought up, let's go ahead and make a note. All your equations must equal 0 to start. The first 3 are set up for you. Number 4, you actually have to rearrange. Add 8 over to make it equal 0. And then when we go to graph it, we just think of that 0 as a Y. And we go through all the same graphing steps we've done before. So first we list A, B, and C, and then we do the axis of symmetry, which is negative B over 2 times A. Because we want to know the center of the graph. Negative B over 2A. AX squared plus BX plus C. Okay. Alright, -3 over 2 times 1, which means our axis of symmetry is -3 over 2. Let's go ahead and put that in decimal form. -1.5. You'll see that your graphs get a little more complicated in this chapter with things like decimals and fractions. And actually, if you have your own graph paper, you might want to do this on a great big piece of graph paper. Because sometimes fitting it on this little square is frustrating. You can, but if you have your own graph paper, go for it. Alright, so how do we do 1.5? Well, this is the x-axis. Here's -1 and -2, so 1.5 will just go right in the middle. There's our dashed line. And our next move is to figure out that vertex. So we will plug in -1.5 for x. So I want to see everybody practicing this with their calculators. Give yourself a chance to practice it before a quiz or something, you know? Practice it now. So many students are putting this into their calculator right. They know the process, but their work isn't showing it. Only because their calculator isn't being used correctly. And that's frustrating. You should get it right if you know it. So, start your calculator. Or do it. What's your style? That's it. So far, we have a right answer. Over here, you have to put parentheses around this one. Put the little two on the outside. These parentheses are all parentheses help. I'll give you a clue. You have to put parentheses here. If you don't type the parenthesis button in the calculator, it will not come out right. You have to have a parenthesis before the negative sign. And then the parenthesis does not include the 2. Raise your hand right now if your number didn't come out. Oh, the number is -0.25. That's what you should get. So if you can't get that number out, let me know so I can help you. So right here, around this -1.5, we want to put parentheses. What did I just do? So parentheses.
Oh my.
Okay.
With the 1.25?
No. Sorry. 1.5. 1.5, right? My bad. So it's just the parentheses that are making it come out wrong.
Okay, thank you.
It's not right. It's -0.25.
Wait, what? How? How? Actually, when you no, wait, like I did it all by myself.
Did you do the parentheses?
No, I did it all.
Yeah, exactly. Exactly. She can't do it all. It's not gonna come out right. She said that. She said you have to include the parentheses in the calculator.
I really got it, not like you. Oh snap! Oh. What are you gonna do? That's why you needed this.
No, -1.5 is giving me your vertex. Because I want to make a whole graph.
Oh,
So
no.
we're going to make a graph.
Oh.
You jumped ahead to solve it. Great. Good. Keep going with what you're doing. All right.
Oh. Oh, no. Oh.
Are you confused about how to graph, Jaden? Are you good about how to graph this? Because you know it does say graph. Okay. All right. So I've gone through the steps to find the vertex. It's in a weird spot. -1.5, -2.5 is kind of floating here. It's about the quarter of the way down. That is officially your vertex. Okay. Now the next step in making a graph is using a table. So we got X, we got Y, we put our vertex in here. We're supposed to do 2 points less and 2 points more, so I'll go with -2, -3, -1, and 0. We'll plug those in, make a whole graph, and find the x-intercepts.
So why are we finding the x-intercept? Oh.
When it says solve, that means find x-intercepts. Which it would be great if they were a little more clear, like find x-intercepts.
I said 1.25.
Oh, it's supposed to say 1.5.
What? Oh, okay.
Yes, it is. Very good. -2 is 0. -1 is 0. Yes, 3 is 2. We already found 0 is 6. That's the y-intercept. Good job.
Whoa, whoa, whoa. Is it 6? Oh.
So use your calculator or do this by hand since the rest of them are decimals. You can do them by hand if you want.
Oh, -1.
And see how much you get out. I'm going to put great big stars next to -2 and -1. These are the numbers that we were looking for. These are called roots. They are the solutions. And they are the x-intercepts. So when we are asked to solve, we will box the answers x equals -2 and x equals -1. Those were the two numbers we were looking for. Who's got a question? No, if you're checking this, okay, I'm going to talk about factoring for a minute to show you a shortcut. I don't like to make graphs. Like, if I can avoid making a graph, I do. Like, for me, other methods are much more quickly done. I would prefer to factor this. So, to factor this, I would say, well, what multiplies to 2 and adds to 3? 1 times 2 is 2, and 1 plus 2 is 3. So this standard form equation factors into this. If I FOIL this, I get that problem. Okay? These are equivalent. And when I see this, I see this equivalent form because I Now, if I solve both of these, I set these little parentheses equal to 0 and I solve, I get the answers, -1 and -2. I much prefer this to make it a whole graph. This process is long, it's a beautiful visual, I appreciate it, but I'm looking forward to when we factor it because I think this is a little more quick. Do you guys see what I've done here? It's the
X minus Q or whatever, and then X minus P. Using that one.
yeah. I'm seeing what numbers multiply to 2 and add to 3.
So that's just another way to do it.
This is just another way to do it. We will spend more time this year doing it this way than we do making this whole graph. But you are supposed to understand that these 2 points on this graph are the same as factoring it and solving it. They are solutions. Okay? All right, you guys have